Good afternoon and welcome to the side event hosted at the European Union Pavilion here at COP26 in Glasgow. Today we have an event on from climate research to climate services and how space can contribute. So a very key topic for this conference, and I welcome you all here and the remote guests who are following us. And I'd like to immediately pass the floor, but just mentioning before that this is an event which is jointly organized between the European Commission, the European Space Agency, EUMETSAT, which is the European Meteorological Organization, and ECMWF. So I'll pass now the floor to John Bell, who is the Director of Directorate C at DGRTD in the European Commission. He's the Director for Health, Planet, Digi Research and Innovation. So John, to you.
Thank you very much. It's really a wonderful opportunity, Simonetta, to be here with you this afternoon. My name is John Bell. I work as Director of the Healthy Planet Directorate, which is what we're all here to deliver in Glasgow. And we're here to talk at this European Union Pavilion side event on how do we move from climate research to climate services, and how do satellite observations contribute. And really what we're talking about is moving from forecasting about the future to living in and with the future. I'm very pleased that we're able to introduce this event in the program of the Pavilion with our colleagues who we work very closely with at the European Space Agency, the European Centre for Medium Range Weather Forecasts, and the European Organisation for the Exploitation of Meteorological Satellites. All organizations who are going to become household names in the future that we're about to live through. You know that the European Union's future is set out in the Green Deal, and what the European Union is for is to ensure that we make a transition by 2030 and by 2050 ultimately to climate neutrality. And this transition, this great transition that we must go through, has to be accelerated in these coming years to the end of this decade. And to do that, research and innovation has to take on a new responsibility in allowing us as a society, as an economy and as an ecology to understand, observe, forecast, model, analyze, draw conclusions, and set out the kind of services and supports that we will need to set our direction of travel and to arrive at a resilient future. And to build this resilience and to deal with the unavoidable consequences of climate change and man-made climate change, together we are going to have to live in a different kind of way. And that is why the European Commission adopted earlier this year the new EU strategy on adaptation to climate change. So for both the mitigation, which is urgent, and the adaptation challenges which are inescapable, climate science research and innovation is absolutely central to improving our understanding of the climate system, to enhance our capacity to address it, and to work alongside with all the other interconnected challenges, such as our planet's biodiversity crisis. What we need to do for the first time in human history is we need to navigate the future by ensuring that we can do transition by design, not by accident. We need a number of systems to change, and for systems to change, we need systemic observation to set a new direction, systemic solutions, and systemic emergence of new services to make that future resilient, accessible, and fair. On the supply side of climate solutions, research and innovation, of course, is ahead of policy. The Commission launched recently a €1 billion Green Deal call under Horizon 2020 with the goal to accelerate the just and sustainable transition for the Green Deal. And if you look at last week's launch on the website of the European Union, you'll see an array of spectacular projects which are trying to make a breakthrough. For example, things like the digital twin of the ocean and the restoration of biodiversity at scale. The call received an overwhelming response with proposals exceeding available funds by multiple. This shows that the vitality and dynamism and ambition of the European and international climate research community is at a critical and a level that is inspiring, I think, some optimism. You know that from the European Union's point of view, in the investment that we make, 30% of the overall budget of the European Union, what's called the Multi-Annual Financial Framework, and the next generation EU budget for investment will address climate change across all of the policies and programs. And 35% of the budget of our new European Union Research and Innovation Framework Programme, what we call Horizon Europe, will be committed to climate-related activities. This is a 95 billion euro programme. So this is a major moment, I think, for the development of this next climate future. For the coming years, Horizon Europe will be a key instrument and an engine to accelerate Europe's recovery from the pandemic, to drive its preparedness and resilience, and to achieve, accelerate, and enable the Green Deal objectives to take place. Transition by design through collaboration with engagement with the public and the scientific community setting direction. But to get to where we want to get to in Glasgow by 2030, we need a decade not simply of investigation, but a decade of deployment. The effort needed to be deployed through a coordinated and transdisciplinary strategic research, innovation, and investment agenda result from a close cooperation between scientists and practitioners, the people who are actually working in and mapping out and living with the ecological and social transitions. The way in which science, society, and the planet interacts is something which has to evolve too. And this is the importance of our event today. In this context, we aim to mobilize very significant investments to make our climate and integrated assessment models more accurate at the global and regional scales. More activities are needed on climate observations and the analysis of climate processes that are not well understood. Many of our life support systems need to be fully understood and projected at different levels of precision and understanding. And that is why in the first calls of this new Horizon Europe programme, we have started to do this through the investment of more than 250 million euros over 2021 and 2022 to get things started. Therefore, I'm pleased to announce in this context that the Commission is collaborating closely with our colleagues in the European Space Agency to bring together major ESA space programs and science right into Horizon Europe in the period following 2024. The European Space Agency will coordinated research topics to support solutions in climate research. So bringing the heavens and the earth together to set a new direction. Two examples of the work with our colleagues in the Space Agency will include developing the next generation of biodiversity observing systems and science-based solutions to address better the primary causes and drivers of this catastrophic biodiversity loss. Secondly, enhancing our observation capacity and the fundamental scientific understanding to deal with the coming climate disruptions. And in all of this, science needs to work in close cooperation with civil society, as we've seen in the COVID period that we're moving through. When science and society works together, transformational changes and resilience are possible. And also, before concluding, I'd like to draw your attention to the Horizon Europe missions, which have just been launched, such as the mission on adaptation to climate change and the mission Restore Our Ocean Waters by 2030. These are game-changing attempts to mobilize and connect, using all the science and innovation that we have, systemic solutions that will allow us to actually get to where we need to get to by the end of the decade in dealing with these systemic disruptions. We aim to reach a vast range of stakeholders and resources towards this objective and accelerate the demonstration that solutions exist for climate resilience. You know the old saying that the difference between optimism and hope is a good plan. Well, that's what we need to develop through these missions. And in closing, let me reiterate that addressing the unique set of global challenges that society is facing at the onset of the 21st century, that's right at the center of our discussions here in Glasgow today, will require greatly that the scientists advance their understanding of our planet, the understanding of the life support systems, and the basis for solutions that will shape the world in which we live in a very short few years. We need to connect the great observation, modeling, and forecasting systems that science has created for us, and we need to mobilize them to develop the services that will be needed to make this great transition a possible and accessible one for all the peoples who are involved in dealing with this time of resilience. We need a new ambition for science and research innovation in real time, so that the understanding of our planet's life support systems allow us to adapt and move and change and prosper. This opportunity to join you at the beginning of this very important session. Thank you very much.
Thank you, John, for these important words on the challenges of science in support to climate change and the work that is done by the European Commission and the partnership we have, of course, with the European Space Agency. I'm Simonetta Kelly. I'm the head of Program Strategy and Coordination Office at the Directorate of Earth Observation in ESA, but I've been also appointed the next Director of Earth Observation in the agency, and that's why you don't have Tony Tolkan-Nielsen, as was mentioned in the program. You have me today, so I will moderate the session and spend a few words of introduction to this panel. So today we have a climate crisis, but the crisis, as we've heard also this morning from the words of Sir David Attenborough, is turning into an emergency. We have more and more CO2, which is released into the atmosphere every year as a result of coal, oil, and basically gas production. Human activities are producing greenhouse gas emissions with no sign of slowing down. And we have more and more increasing trends in disasters, and as we've seen this summer with all the events in Central Europe and fires in Greece. 90% of disasters are now classed as weather and climate related, costing the world economy billions of euros each year, and while millions of people are pushed into poverty as a result. So we are far from powerless, and we have to face this global threat all together. And I think COP is really the context where we can join forces and go to actions and to plans, as John just reminded us. While science tells us that climate change is irrefutable, it also tells us that it's not too late to stem the tide. This will require fundamental transformations. Aspects of all society need to be changed: grow food, the way we use land, the way we use transport goods, and how we power our economies. And last but not least, of course, we have to develop and use the new technologies which are available. International bodies and governments, they across the globe, are setting net zero emission goals, including the European Commission, as you know, by 2050, and putting the onus on all of us, institutions, corporations, and individuals, to make changes. Decarbonization is the route to meeting these goals, but progress must be measured, and establishment agreement compliance with support from space is our proposal. Space represents a strategic tool to support all these climate change challenges. To be successful in this, scientists need to advance in the understanding of the planet. We need to understand the interaction with human activities and translate that knowledge into novel solutions and information services for society. To do this, we have to work together, and we recently launched a partnership arrangement and a cooperation, as you heard from John Bell, between the European Space Agency and the Commission, DGRTD, which is called, basically, it's an Earth Science collaboration initiative to join forces and ensure our actions and programs complement each other. What we have done is to work on the Horizon Europe activities in coherence with what ESA does in terms of programs in climate field, including the CCI, the Climate Change Initiative, and the Copernicus services. And we will support scientists. We will help them in gathering the data, using that at best, understanding our planet, and fostering the transfer of knowledge into solution and climate services. Only joining forces across Europe and partnerships, we will be able to face this challenge. And that's why the side event has been organized jointly between UMETS at the Commission and ECMWF, which is the European Center for Medium Weather Forecast. Technology has contributed to climate change effects, but efficient technologies and new scientific insights can also help us to observe and monitor the effects, and might eventually reduce net emissions to create a cleaner world. Satellite technologies can support priorities of the European Union, like the Green Deal, of course, and the digital agenda. And we have today available satellites, which are the Copernicus Sentinel satellites, jointly developed with the European Commission. We have scientific satellites mission called the Earth Explorers, which give a lot of data supporting climate change activities in the field of magnetic field, ice melting, but also soil moisture. And we do have the meteorological mission, of course, developed with UMETSAT. Its activities nourish the entire food chain of providing high-quality, climate-relevant data from satellite development to climate data record creation. And we do keep archives of these data available for all scientists all over the world that can access those data free and open and use those data for the models. These observation records provide the observational evidence underpinning knowledge of the Earth system, and it's reflected in the contribution to the IPCC report that was recently published in August, where you could see the increased rate of data used by scientists and space data in particular in support of the models, especially in the area of ice monitoring and also land monitoring. And we do support the implementation of the Paris Agreement. We have, in fact, some dedicated missions called Sentinel expansion missions that will be developed in the coming years, including a CO2 anthropogenic mission that will be deployed in support of the global stocktake in 2028. ESA, the Commission, we work on the climate services together, of course, with ECMWF, and we're engaged in a coordinated effort to ensure this happens, promoting the transition from advances in Earth observation and climate research into climate services and solution, of course, for citizens. And here we also have to look at citizens and their business and life. In this sense, we can say, let's make space for Europe, let's make space for our future. Thank you. So as I'm also the moderator, I have two hats here. I will also introduce now the next speaker. This is a presentation that has been prepared jointly between the European Commission, DGRTD, and ESA, my colleagues on the Earth Science Partnership I just mentioned you, and it will be delivered by Philippe Dulkens, who is the head of Climate and Planetary Boundaries Unit at the European Commission, DGRTD. Philippe, I pass over to you, and you can talk about the Earth Sciences cooperation we have. Good afternoon.
Thank you very much, Simonetta. If one can upload the slides, we'll start, and I will do the risky exercise to improvise on the slides, because John Bell and you, Simonetta, have introduced the topic very well, and I will avoid to repeat what has been said. Next slide, please. So first, let me congratulate you, Simonetta, for your nomination as Director of Earth Observation Program at ESA. The messages that I have for this presentation are quite simple. I hope they will be clear. We have all seen that if we now have a global climate policy and EU climate policies due to the outstanding work of scientists since several decades, actually. And now the grand challenge is that we are facing is that the understanding of the planet needs to continue to advance. The process, the interaction with human activities need to progress, but we need really urgently to translate faster and better the knowledge into novel solutions for society. This is the challenge for now. And as a European citizen, if we ask them, what is the EC, ESA, UMETSAT, ECMWF? I think that most of the people would be confused. What counts is that Team EU delivers and delivers the solution. And what we are trying to do here through this cooperation between the European Commission and ESA is to fight this fragmentation of activities and work together with our respective capabilities and expertise to address key societal issues. Next slide, please. Next slide. I don't see them changing, but that's okay. Okay, well, that's about the capacities that we have, which are very large in terms of satellite coverage. Through different entities, through Copernicus, to the ESA, to UMETSAT. And the capacity in Europe is outstanding, but we need to go beyond that. We need to use also other types of data. If you can click on the arrow, the down arrow, you will see some items popping up on the screen normally. We need to add other type of data, in situ data. We need to relate to the models and to the forecasts. We need also to perform interdisciplinary and open science. And of course, use all the new capabilities on ICT, on cloud computing, artificial intelligence to crack this knot that is extremely complex. Next slide, please. These were the items that were supposed to come, but the synchronization is difficult in this virtual form. So we can go through the next slide, which is quite pragmatic. It's just to show that both ESA and the European Commission are trying to coordinate their activities for to offer more opportunities for researchers and innovators. Horizon Europe has started. The work program for 2021 and 22 is, well, some of the calls have been published, more will come in 2022, and we are preparing coordinated calls with ESA for 23 and the following years. Please, if you can click on the down arrow, exactly, it shows simply the sequence. The message is very simple here. We are thinking about the coordinated programming, and new opportunities will be offered to researchers to team up between the capacities of Horizon Europe to mobilize the research community and the strong capacities, of course, at ESA on satellites, data, and the usage of those. Next slide, please. With regard to the flagship action, some already have started on biodiversity, on polar regions, on ocean health, and new will be coming. If you can click on the arrow, the down arrow, we'll have others on water resources, food system, terrestrial carbon, air quality, and health. And as you see on these upcoming initiatives, we try to get closer to what speaks to citizens, what is really needed to transform society. John Bell referred to the missions on adaptation to climate change and the mission on restoring our waters and ocean. These are key to show that research and innovation has the power to transform society if we bring the results and the solutions to those who can implement them. Please, next slide. So the activities will take place as coordinated calls and opportunities for the researcher to cooperate from both ends. We are planning several topics contributing to this initiative in Horizon Europe, is in what is called Cluster 6 of Horizon Europe. And of course, a key component of these activities will be the dissemination and exploitation of the results. I never insist enough on these. The role of the researcher has changed. You see the youth being mobilized so much for a change. Researchers also need to go beyond what they have used to do, progressing knowledge, and make sure that the results that they develop, the solutions that they propose, are indeed being taken up by other actors so that they can be deployed faster. Please, next slide. In this cooperation with ESA, I would like to also stress that there are some events where that are gathering a large number of participants, and ESA is really excellent at organizing public events, such as the Polar Science Week, EO for Agriculture Under Pressure, EO for Water Cycles, the Ocean Digital Twin of the Earth session at the ESA Fee Week, and others, workshop under preparation on biodiversity extremes, climate extremes and natural disasters, ocean health. We'll have other events in 2022 in the Symposium of the Living Planet, and I would encourage you to follow them. Please, next slide. ESA is also investing in new ESA missions, the Earth Explorer, such as Earth Care, Biomass, and Flex. Earth Care will advance our understanding of the role that clouds and aerosols play in reflecting incident solar radiation back into space and trapping infrared radiation emitted from the Earth's surface. Biomass will provide estimates of biomass over tropical forests, enhancing our understanding of the terrestrial carbon pulse, and fluxes. And as you know, the carbon budget is such a key issue where uncertainties needs to be reduced. Flex will give us new high-resolution information of the vegetation fluorescence, which is an indicator of photosynthesis and plant stress. Next slide. The next slide is about Horizon Europe. It's much less sexy to sell than satellites and observation, but it's an important information for the researchers who look for opportunities and to apply to the calls. If you see here at the center of the slide, in red, you will see reference to cluster 3, 4, 5, and 6 of Horizon Europe in the pillar 2. That's where the greatest part of the investment in Horizon Europe is. And I would encourage the researchers or the entities that represents them to really look in more than one cluster. There are calls that are relevant to your activities on observation, on climate science, on biodiversity, and so on, in several of the clusters, because the issues have been mainstreamed. So one should look at the cluster 3 on civil security for society, at cluster 4 on digital industry and space, at clusters 5 on climate, energy, and mobility, and finally at cluster 6, food, bioeconomy, natural resources, agriculture, and environment. Also, not to be neglected, the look at the opportunities in the research infrastructure part of Pillar 1 of our Horizon Europe. This is a big program. It's a massive investment, as John Bell recalled, more than 94 billion euros over 7 years. And this means many opportunities for the researchers that need to be seized to provide the solution that society needs. Next slide, please. Just to summarize, we have been establishing excellent cooperation between EC, ESA, and the other institutions here represented today. The first set of activities are being launched and more are being prepared. And we look forward really to the continuation of this cooperation to have more impact and to show that through research and innovation, we can bring solutions and therefore hope for society to save the planet. Thank you very much.
Philippe, basically, this is very interesting as a context setting of the Earth Science collaboration. We're here in a COP context, so not just a European one. You've heard the European perspective, but I think there's a lot of potential also for scientists outside Europe to access through this mechanism data and scientific collaboration with Europe in the field of climate research. And so I think it's a very valid frame that was put together. And you said the satellites are sexy, but what's even more sexy, I think, what we do with the satellite data. So now the next speaker is going to be Susanne Mecklenburg, who is the head of the climate office at the European Space Agency in Harwell. And she will tell about the climate change initiative and what we do with the data from our satellites in support to climate change. So Susanne, to you.
Thank you very much, Simonetta. If you could bring up my slides, please. Yes, if you could go maybe one back or two.
Are these the ones? Yeah.
Yes. I think that's not the first slide, is it? Yes, no, sorry. I just wanted to sort of on this first slide say, now we've heard a lot about a strategic background and how we are organizing ourselves in making these space-based observations usable and actionable in a more, let's say, a service and policy-making context. But I thought I'll come a little bit back to the essence of these data, and I wanted to show you a couple of examples from what we can actually do and use from our space observations. Next slide, please. Now, first I wanted to show you a couple of images which were very enlightening this summer. I had the opportunity and incredible chance to go to a mountainous area in the Swiss Alps, where we were going on an expedition with one of our astronauts, Luca Parmitano, to basically put together a documentary about the melting glaciers in the Alps. And we were there for a couple of days, 3-4 days, and it was, for me, a very eye-opening thing to see how you can actually really see, like you see in the middle, the retreating areas of the glacier in the valley. And the funny thing was that I bought a map before we went out, and the map was from 2015, and it was totally incorrect by the time we got there. And that's only 6 years later. So that was really an eye-opener for somebody who's probably somebody who's looking from towards the Earth from space and at her very safe desk. So it was nice to have that sort of hands-on experience. It also brought the message back what we actually see from space. So we basically see certain parameters, but we are not seeing necessarily exactly what is underneath. So we went, for example, into caves under the glacier, and that was for me, something to understand that by everything that we're using from space is actually an extrapolation of what we would like to know about the surface of the Earth, and that's another message to bear in mind. Next slide, please. Yes, this morning already we had a number of announcements and summaries from the recent publication that came out of the Intergovernmental Panel of Climate Change, IPCC. They released their Assessment Report 6, Working Group 1 report in August this year. So this is the report that deals essentially with the physical evidence. And it essentially confirmed what we already know, that it is undoubted that human influence has warmed the atmosphere, ocean and land, and we know that. But I think the new thing in this particular report also was to really realize the acceleration of this warming that we have observed over recent decades. And then one sentence in particular sort of caught my eye, maybe coming more from the sort of satellite area, saying methodological advances in new data sets contributed approximately 0.1 degree to the updated estimate of warming assessment report 6. So that also includes information that we get from our satellite data, and this is a little bit what I wanted to show you in this presentation. Next slide, please. Now, coming a little bit more to the actual satellite data, they have, of course, the beauty of being long-term, timely. You have collocated data sets, so over one point on the Earth you have different data sets. So this is something that is the advantage of data from space. And that's what we are exploiting, let's say, in our ESA climate office. We are at the Harwell campus near Oxford here in the UK. And we have sort of a different remit, let's say. We implementing the Climate Change Initiative, and I'll come to that in a minute, our flagship program, but we're also working a lot on international policy level. So we're working with all the organizations that are here in this event and many more also on the scientific side, like, for instance, the Global Climate Observing System or the World Climate Research Program. And we're an observer to IPCC and UNFCCC. But what the real crux of what we're doing is that we're running a program that entails the quantification, let's say, of the World Meteorological Organization defined essential climate variables. And so a little bit more than half you can observe or benefit from space data. And we are currently addressing 21 of these. And we are providing them in long-term data series to our users in Europe, but also worldwide. Next slide, please. Just to give you an impression, so I'm here more from the sort of scientific side for quantifying essential climate variables. Samantha will more talk about the sort of more operational side, but and we're working very well and close together. But I think in our remit in the scientific world, one measurement for scientific excellence is probably the uptake of the publications that are associated with the Climate Change Initiative by IPCC. And here you see a little statistics, and we really made a change between the last assessment report and this assessment report. And this is something that sort of confirms that quite obviously the papers that are coming out of the Climate Change Initiative have very high quality. And we also were involved a lot in the actual drafting and reviewing of the report. We also have one, for instance, one scientist here who contributed quite a lot to this IPCC report, and I'm pretty sure we'll have something to say in the panel discussion. Next slide, please. But to come back to what we actually see, so I started my presentation with the glaciers, but what we also see, or what came out, is a paper that came out this year, looking at a sort of global picture of glacier mass, glacier ice mass loss. And that's something very new, because there's about more than 200,000 glaciers in the world, but only some of them have been studied very much in detail, let's say on the ground, and combining the satellite and the in situ data. And this particular paper really quantified it worldwide, and you see the different extents of glacier ice mass loss in different regions of the world, which is a first, or is a very new assessment, and a very a comprehensive one that we have seen. And it basically concluded what we also have seen in the IPCC report, that glaciers contribute about 21% to the sea level rise. And this is why we're actually looking at glaciers. Next slide, please. So this is sea level rises in everybody's mouth. If you would have seen this morning's UK's breakfast TV story, then you would have seen the lady introducing the subject by explaining where the water would be on her knee in 2050, in 2060, in 2080. And it's a very topical issue for especially also adaptation measures that we need to think, for example, in a city like Glasgow on the ocean, or near the ocean. Next slide, please. And the way that we're measuring these things is with altimeters, given that the ground track of altimeters is only about 50 kilometers, you have to have quite a few of them to put a good map together. And again, here you see what we have been coming up from the Climate Change Initiative with this curve there, which basically confirms what actually made it into the IPCC report. And again, here you see an acceleration of the sea level rise as well. Next slide, please. Sea level rise is not the same everywhere, and again, here comes in the measurements from space. So, for example, we can it depends on different seawater temperatures, on ocean currents, on gravitational adjustments, and for all of these different influences of how sea level rise is being modified locally, we do actually have data from space available. And then, almost my last slide, I think, another interesting part that I wanted to show you, next slide please, is again a result that came up very recently, looking at relative sea level rise, so basically offsetting, let's say, the actual sea level rise with subsidence. And you can see quite different things. So for example, in North America, the sea level is actually falling due to a land uplift. So basically of the melting glaciers in North America, the continent is relatively coming up and offsetting the sea level rise. In other areas, we have the opposite effect, like for instance in Southeast Asia. So again, a very good illustration of how different satellite data actually contribute to a very complex picture in sea level rise, and how we actually not need to look at only one data source, but we need to intelligently combine them and look at the overall picture with many different measurements to be made. And I think that concludes my presentation for this afternoon. Thank you very much.
Thank you, Susanne. Thank you for this comprehensive overview of what you can do with the satellite data on the scientific research side mostly. So now we're going to talk more about the operational elements related to climate change, and I would like to pass the floor to Samantha Burkus, who is actually the Vice Director, Deputy Director at ECMWF of the Climate Change Service. So Samantha, you have some slides as well, I think.
Thank you, Simonetta. Yes, if my slides could be brought up, please.
To see is really the complementarity between the research elements that were stressed by John Bell and the operational elements that I'm sure you will very well describe. Can we have the slides of Samantha? Yeah,
Great.
Perfect.
Great, thank you so much. And it's always fantastic going last or towards the end of the panel discussion, because there's so much of what you want to introduce in terms of the big strategic picture and the science behind the satellite observations has already been covered. So if I could go on to the next slide, please. For those of you who are unfamiliar with the Copernicus Climate Change Service, we're an operational service, as mentioned. We're hosted by ECMWF and act as an entrusted entity for 2 of the 6 Copernicus services. And the event after this one, you will learn more about all of the other Copernicus services and the data that we use for climate adaptation. And the Copernicus Climate Change Service has been live since 2015. We have over 100,000 registered users globally. And what we do is we combine observations, primarily satellite observations, but with other in situ observations as well. And we process those and make them free and openly available in the Climate Data Store. And this information is available for society, for legislators, for business, for everyone to use for their climate adaptation requirements. At this point in time, we have over 100 catalogue data sets that include climate from the past, climate from the present in terms of seasonal forecasts, and climate predictions for the future in terms of the same data that was used in the recent IPCC assessment report, the CMIT-6 climate projections. Next slide, please. I won't spend too much time on this slide because Susanna gave a fantastic overview of essential climate variables. But C3S hosts 23 of these essential climate variables. And as already mentioned, these essential climate variables really need to be long-term, they need to be consistent, and they need to be complete to be climate data records that recognize and enable us to understand our climate state. So all of these essential climate variables are from either single or multiple sensor approach, and they're regularly updated in real time, and they're very accessible and traceable. So all of this data is transparent and traceable so that anyone using this data understands the source that it comes from. Next slide, please. And what we do with this data, our most popular product is called ERA5, and it's a reanalysis product. And what that means is it takes the global observing system of the climate system, it combines it with the latest numerical weather prediction model, it assimilates this data together, and it creates reanalysis, which is effectively maps without gaps. So in Europe, for example, we're extraordinarily fortunate that we have very long climate data records. Many other parts of the world don't have this data availability, so reanalysis really helps to provide this information of the last 70 years. So our record is 70 years at this point in time, so it's near real time. Our October release will occur later this week, and it goes back to 1950. Another large part of our program is rescuing the early satellite data and also in situ observations as well. So building these old data records that help complete this picture. Next slide, please. And we have a whole range of different reanalysis products. So ERA5 is the one that I mentioned, that is this map without gaps, and the resolution globally is around 30 kilometers, and it's 5 days behind real time. We then have a higher resolution terrestrial product called ERA5 Land, and that resolution is 9 kilometers. We then have 2 even higher resolution products. We have a European regional reanalysis, which is done in collaboration with the scientific community and with national meteorological and hydrological services across Europe. And we also have an Arctic reanalysis, which is one of the really exciting products that we have. At the moment, it's just 2 zones within the Arctic, but in the current phase of Copernicus that we've just started this year, it'll be across the Arctic, going to near real time and going back to 1998. And this is at a 2.5 resolution. And sorry, it will actually go back to 1991 over the next couple of years. And you can see in this slide the indication of the global product with the 30-kilometer resolution versus the higher resolution European product and Arctic products, where you can understand the details of the climate in greater geographical scope. Next slide, please. And what this means is that we're able to monitor the climate. So the Copernicus Climate Change Service provides both monthly and annual monitoring products, and then our data goes to many, many other sources. So one of the other data portals that we may hear about later today is the Climate Adapt portal, where the European Environment Agency uses C3S data to provide information to European citizens to plan their climate adaptation strategies. And we also show climate indicators where you can understand how sea level has changed through time, understand the cryosphere, look at the different cryosphere metrics, so looking at ice sheets, glaciers, and sea ice, and understand how this has changed through time. Next slide, please. And we have many, many examples of how we've applied this data, both data from the past, data projections for the future, to understand implications for our changing world. We heard in John Bell's presentation earlier about the biodiversity crisis. So we have an application that looks at the future of biodiversity, and it looks particularly at Natura 2000 sites within Europe, uses the CMIP6 climate projections, and looks to understand what implications there are for biodiversity changes with a changing climate. And another product that we have available through the Climate Data Store is an insurance service, where again we use the operational windstorm service, and it provides storm tracks, footprints, summary data, and loss estimates based on the ERA 5 reanalysis. I think we're very short on time because of these very interesting talks, so I'll just go to my final slide. As Susanna mentioned, we're an operational service, and that means that we have a full user support system in place. So the data is free and open. Next slide, please. Oh, sorry, I skipped a slide. So the future of reanalysis. So when we're talking about the amount of information that we have available, this has increased almost exponentially through time, through the age of the satellite era. And the exciting update for ERA 6, which we're producing over the next 5-year period, is looking at a coupled ocean atmosphere model. This means it will be much better representation of key atmosphere ocean processes and feedbacks. And in the example you can see here is a very famous image. So it's the Apollo 17 image of the Earth that was taken in 1972. And the image on the right-hand side is the ECMWF forecast initialized from the ERA 5, so the existing generation of reanalysis. And you can see a lot of similarities in the cloud structure of the Earth on that day in 1972. So it's incredibly exciting, the developments that will take place over the next 5 years. And I've already described the final slide, which is if you need any further information, here's where to find us. And our user support team is very happy to help. Thank you very much.
Thank you, Samantha. It was very comprehensive on the operational climate service. And now, last but not least, of course, we have a last remote speaker, is Jörg Schultz, and he speaks from UMETSAT. He's the head of the climate service and product manager. He's actually product manager for climate service and products and at UMETSAT. So Jörg, I hope you hear us and that you're connected. We have time constraints, but we'll let you speak, and we'll shorten the Q&A, of course, because all the interventions were very interesting today. Jörg, to you.
Okay, thank you very much. I hope you can hear and see me clear, and I can also see the slides. So as Simonetta said, my name is Jörg Schultz. I'm with UMETSAT working in Darmstadt, but I greet you tonight from the city of Bonn, which is actually the new location of the Copernicus Climate Change Service. So can I have the next slide, please? So just to give you a little insight, so we go a bit back to the satellite data. So UMETSAT is the operational organization providing satellite data, and we do this actually for weather and climate. And I think both are very important in the context of the changing climate. So the climate data records, you have heard a lot about them. And also EUMETSAT is producing many of those. And we do this, of course, in cooperation also with ESA. So it's a very complementary set of these ECVs that you have heard about that we together provide. Basically, there are not many missing that can be accessed actually from space. But also weather. So many data that we have go also in weather forecasts, national weather forecasts, but also at ECMWF for the medium range. And those are, of course, very important, in particular, if you think about extreme weather that is happening more often and more likely, and probably also stronger in the changing climate. And of course, many of the information that we provide ends up in all these regular reports that many organizations like WMO and IPCC give out. Next slide, please. So just we have heard a lot about the value chain, how do we work together? So this is depicting this a little bit on the left side. You see that's the infrastructure in space. So long-term satellite programs, and on the operational side, this also provides a lot of sustainability. So our programs that we develop together with ESA are actually will be in space, and we have a commitment to data provision up into the mid of the 2040s with those programs, and that really provides many data that also support the implementation of the Paris Agreement and the global stocktake. So we can work a couple of these stocktakes happening every 5 years with those data sets. But also going back in time, and we have seen that in Samantha's talk already, so data rescue is also very important for historical satellites, and I will show you a picture how far we probably go back. So at EUMETSAT, we do a lot of data records, and that's actually also complex science involved in doing that. And then, of course, there are many users on research, but also National Climate Services and the Copernicus Climate Change Service, and researchers use that, and the results of this research you find often in the IPCC reports. And this is providing the facts actually for policy making in the range of the UNFCCC. And what I wanted to say on the space segment, one little element, so in the very future, together with the European Commission and also with ESA, I think we're going to launch the CO2 measuring mission, and that is really providing CO2 and methane estimates that will be used to support verification systems for emissions of CO2, and that's a very important mission in the relation of the Paris Agreement. All three organizations actually work closely together. So next slide, please. So just give you an impression on the challenge, what it means to do climate data records with satellite data. And we probably just look at the figure. We have no time for the words here. So this is a tapestry of past satellites in geostationary orbit. So this is those one that are sitting particularly over one point over the equator, seemingly, and those you watch in evening TV where you can see the weather forecast. And this is the whole international fleet of this running by the United States, Europe, and Asian space agencies. It's about 50 satellites, and you basically need to work with all of them to produce a meaningful climate data record from these data. So you need to calibrate them, you need to cross-calibrate them to really arrive at a harmonized and homogenized data series that you can really use to depict change and variability as well as you need it to make all these nice statements that you can find in the IPCC report. Next slide. So how far back can we go? So what you see here is a very old picture. So it's a composite that consists of about 450 photos taken by a NASA satellite, TIROS-9. It's just a video camera, and that is actually from February 1965. So that's incredibly how far you theoretically can go back. Unfortunately, most of these data are not really available in digital form. So you probably have photos like this that you may try to digitize and really make this into data. And on the right side, I don't know if you can start the movie on the figure on the right side. If you would hover over the image and click the video start button. So this is what you see from our modern geostationary system of EUMETSAT Severi over the Indian Ocean. And that is actually a cyclone called Fani in May 2019. And that was the strongest actually that hit the Indian subcontinent in the last 20 years. And you see that has a much higher capability with about 15-minute sampling. So every 15 minutes you get a picture like this, from which you can derive, of course, much more features of the storms, and that you can really do warnings, and you can also understand how the storms actually evolve and how they move and how they fall part at the end when they go over land surfaces. Okay, next slide. I need to really speed up. There's one other thing, how the chain works. And we have heard Samantha, and the Copernicus Climate Change Service is actually giving bulletins every month. Those I write down. So what was important about the climate in Europe. And you see these statements in the box on the upper left. There's a key messages about the sea ice extent. And this you can find also in the reports. The data for this were actually provided by the Humansat Ocean and Sea Ice Satellite Application Facility. And they do these ice charts, as you can also find on their web pages. And the data, of course, publicly available and, of course, freely available. But these, to do this, they also need input data. And the input data are basically provided by another Humansat Satellite Application Facility on climate monitoring. And they work not only with Humansat data, but also with data from our American colleagues, a very old instrument series that still exists into the new, and they provide the inputs from which the sea ice extent data actually derived. And this is how these different entities work together, and the service is using that then for making these bulletins and inform the society and others about this the changes and the sea ice over the year. Next slide. Samantha was also talking a lot about reanalysis, and this is where I can say that Humansat and ECMWF have actually a very strong partnership on that. We have a special agreement that we are just renewing under the European Union financial framework. And it is clear that the reanalysis has a pretty large impact. And you can see this and note that if you also look in the IPCC report. And Humansat is actually providing a large set of fundamental data sets from satellites that are curated and quality controlled and really made ready for the assimilation. So we run tests with ECMWF and help them actually to assimilate the data into the model. And but on the other hand, the reanalysis itself is also, there's a process underneath, and that really drives consistent improvements across the Earth system science component. So we can learn also a lot about our observations by bringing them into contact with the big model at ECMWF. And this is very valuable for us because we can use that also to investigate historical observations that have not been assimilated so far. And you have heard that the reanalysis is going back to 1950, so this is far beyond my historical background that I showed to you. Next slide. And that's a second last. So one thing that is very important when you work with space data is the user engagement that always needs to be enhanced. And that's true, I think, also for all organizations that spoke today. Because we understand our measurements and we can produce lots of products, but how do you really reach the usage of these products? And that is at least the same amount of work that you need to put on that side compared to what you put in making the observations. So there's a lot of thematic subject experts that are needed to interpret these measurements and bring them into services. And you also need to tailor services and the data for those services. So there's a lot of additional work from just a pure ECV data record into the usage in a service. For example, if you want to use data for making it useful for solar energy applications. And so this is a lot of refinement that is needed. And then, of course, the service delivery. And this is where you see that the Copernicus Climate Change Service has, of course, a lot of strengths and professionalism developed in doing these service component. And then you hopefully, in the end, you can really support the policy making at the end of this schedule. And Humansat is actually helping.
You have the last slide now, because we're almost out of time. Yeah.
Just one sentence on the other one is strengthening also the technical sectors where the data are being provided to users. And this also involves a lot of cloud infrastructure that we jointly develop, which is called the European Weather Cloud. That will probably be a platform for many people working with the data in science and services to really get the best type of access to it. And the four messages that I can leave you with is, so we have seen long long-term sustained observations from space are really key, and we need to do everything to maintain these records and create new ones, as you have seen in the EC presentation at the beginning. The creation of these data sets is a complex science, but it's worth doing it because we can go back into the 1970s and times where climate change was not on the agenda and it was just starting to accelerate. Production delivery need to use cloud infrastructure to cope also with the data volumes, but also to provide better user services, and the tailoring of products and the coordination with the users in using the data is of a real importance. So thank you very much, and I hope you could see and hear clearly.
Yes, Jörg, we could see you clearly, and I think this is a perfect conclusion of this session, where you could really see the relevance of space in support of climate change in general, with the scientific perspective, the research one, complemented by the operational one, which was clearly presented by ECMWF, and the collective effort of Europe in support of climate challenges in general. I have a question here. I will reply briefly. We have a question how to access the ECV's results from the ESA CCI initiative, and this is from the ESA webpage, so it's easily accessible for everybody. And with this, I'd like to thank all the speakers, those who have intervened remotely, and those who are here in presence. And I look forward to the next few days of work and also of dialogue with you all. I think here we have an impressive community of users, of scientists. It's a unique opportunity of politicians, decision makers. We all meet at COP, and I think we all join efforts on our side to present you what's relevant in terms of space in support of climate, but for meeting our challenges together. Thank you very much. Bye.